All right, ladies and gentlemen, today we are going to go and start basically our first lecture when it comes to thermodynamics. We're going to start with the easy stuff you probably have heard before, but we're going to try to put a thermodynamic spin to most of this. And so I guess when we start with thermodynamics, the first thing we should do in thermodynamics is define thermodynamics. What is thermodynamics? Okay, so thermodynamics. This deals with the relationship between heat and the other forms of energy. So it deals with the relationship between heat and the other forms of energy. And you might be wondering, what are those other forms of energy? Well, they're going to be something like mechanical energy. There are going to be things like electrical energy. There are going to be things like chemical energy, where we could also talk about, nuclear and all sorts of other things there, but let's just stop there. And then we're going to say, continuing on, and the interconnectability of these forms. Okay, so what we're going to find out is energy is energy. It can be used in many different ways. It can be created in many different ways. It can be transferred in many different ways, but we're going to just try to understand that in thermodynamics. Okay, and so basically it's a relatively new idea in the 19th century. People began to see, researchers at the time, that hot bodies could do work, could produce some useful work. And that's where this idea came from. Now, to start our study, we're going to do probably the most important thing here is we need to define our system. All right, we must define a system. A system is basically, if we want to define it in words, system is what we want to study. What we want to study. So we were looking at an engine. We're looking at a turbine. We're looking at a boiler. We're looking at whatever that system is. And what we're going to do here is we're going to, I'm going to do this very simply. I'm going to draw a box. This box happens to be the system that we want to study. Okay. Now, everything outside of the system is going to be called the surroundings. This is everything external to the system. Okay, makes sense. Everything external to the system is the surroundings. But we're going to have to do something to denote the difference between those two things. And that's where we're going to draw a boundary. Okay, so I'm going to say a boundary. A boundary is what distinguishes a system from its surroundings. Okay, so in our system here, I'm going to take a different color here, pen, and I'm going to say that this is going to be our boundary. And usually I put a dotted line here to denote what my boundary is. So this dotted line is my boundary. And when I know that everything inside of that boundary, that's going to be the system, and everything outside of the boundary, where this is going to be my surroundings. Pretty straightforward, simple idea when it comes to system and surroundings. But these systems are probably going to be one of the more important things that we're going to have to work with in thermo. And there are two types of systems, two primary types of systems that we're going to deal with. And the first one is going to be called a closed system. A closed system. And the key thing about a closed system is that is a system that always contains the same matter. Okay. Another way of saying that is no transfer of mass occurs across the boundary. Okay, that's a very important idea. A closed system is closed. It is a box. Let me I have a box here. Here's my closed system, my Amazon Prime box. Okay, I am going to pretend like this box is closed. It's rigid. There's nothing that leaving, no mass is leaving. It says filled with water. All right, that would be a bad idea with cardboard, but that's, you got the idea. It's filled here. No mass is leaving the system. Now it's closed. I could heat this system up. I could put it and heat it up. I could cool it down. Heat is crossing the boundary. It's moving in or out of that boundary, but the system is still closed. No mass crosses the boundary. Okay. There's also this idea of work that we're going to come to. The system can work on the surroundings, or the surroundings can work on the system. We'll define that more later. But the key thing is no mass can cross the boundary. And so this issue right here is always a major mistake. Because one of the first decisions we have to make in class is what kind of system do we have? Is it a closed system, that's path 1, or is it an open system, path 2? The key thing you want to say is I'm going to draw a boundary around that system. And if mass crosses that boundary, it's going to be something that we're calling an open system a little bit later. If mass does not cross that boundary, it's a closed system. It's that simple idea about mass that we need to talk about. However, students can sometimes say, well, heat's leaving the system, it can't be closed. No. The definition of the type of system is always about mass. Okay. Now you see, I'm belaboring this point. I'm bringing it up. You're saying, man, I got it, Wanklyn. You put a circle around it. Yes. But this issue can leave you from going down a path that gets you a lot of points, a lot of great ideas, a way to solve the problem, or a completely wrong analysis I can do nothing with. Okay, so make sure that you put whatever you need. I have this fancy pin here that puts a rainbow on there. This is important. If you see this rainbow pin appearing in these notes, right, you know that that's an important idea. It's a simple idea. It's a simple idea, but note that no transfer of mass crosses the system. Now, there is a special kind of system that is even more than a closed system. It's called an isolated system. An isolated system, it doesn't react with the surroundings at all. No mass crosses, no heat crosses, no work crosses. It is just isolated out there. It doesn't have anything to do with the surroundings. So that idea of isolation is also connected to it's a more specified closed system. The other type of system we're going to deal with is an open system, of course. Okay, an open system. And this is a given region of space through which mass can flow. Okay. A room, when you open the door and there's air moving in and out of the room, or with the air conditioning vent, if you make your boundary, the three-dimensional boundaries of your room, and there's air coming in, there's air going out, that's an open system. Your body is an open system. I put a boundary around myself, a three-dimensional boundary. I'm breathing in air. I'm breathing out air. Okay, so I'm an open system. Mass may cross this boundary. Okay. Again, opposite of a closed system. I want to let you know that there's going to be some words that you're going to hear. You're going to hear the word control volume. Okay, what does control volume mean? Well, if I put a boundary, a three-dimensional boundary around something, it's a volume, right? And if I control that volume, that's basically talking about a three-dimensional boundary. Okay, a control volume. Now there is a special type of control volume that no mass crosses through, and we call that a closed system. Okay, so the boundary on anything, closed or open systems, can be called a control volume, but we specifically call a control volume where no mass crosses through a closed system. Control volume and open system often are used interspersingly. Man, it's late. It's 11:45. I'm recording this for you. My brain's not working so well. They can use they can use in place of each other. Let's go with that. In place of each other. Control volume and open system. Because we're going to say that control volume in general states can have mass coming in and out of there. So recognize that nomenclature, that sometimes instead of open system we'll say control volume. But a special type of control volume, which has no mass that crosses through it, is called a closed system. Okay, so that's what we're working with here. Control volumes have control surfaces. You're controlling that surface that something is going through. That's going to be that boundary, that three-dimensional volume is going to have a surface that basically, like if you're wrapping a gift, you put the wrapping paper over the surface. That's the control surface. Okay, so I'll just put this idea down here of what a control surface is. Okay. Now, talking about these things, control volumes, control surfaces, very important way to start this lecture, and we'll pause right here as we're going to go on and talk about some more interesting ideas.